Hello guys, this is CodeNCode and this is video editorial for the problem largest rectangle in histogram. And the problem is categorized as hard, so let's make this problem easier for us. So the problem statement is we are given an integer array which represents height of histogram bars, and each width of each bar is actually 1. Okay, so we have to return the area, the largest area of the rectangle that can be formed in the histogram. So it is better understood with an example. So suppose these were the height. So if you represent them using histogram, here it is what it would look like. Okay, and so the maximum area that you can form is actually of length, of 10 unit square. Okay, so you have to output 10 for this input. So this is the maximum rectangular area that you can form. So the prerequisites for the solution of this problem is clearly basics of programming, nothing much is required, and the knowledge of stack data structure. Okay, and expected time complexity is linear. Now, one of the first observation is that suppose this was the input and the graph is already in front of you. So this is the question that I would like to ask from you. So this question will help you understand the solution of this problem. Maybe you just after answering this question, it is possible that you will be able to formulate the solution of this problem yourself. So the question is, can we make rectangle of height 4? Remember, this is a specific question for this specific input. This is not a generalized question for every input of this problem. Okay, so can you make a rectangle of height 4? And again, keep in mind that we have to maximize the area. Okay, so just think about it. Can we or can we not? And whatever your answer is, let's discuss it now. Just pause the video and think about it, and I'm going to discuss that now. So eventually that it is possible to make rectangle of length 4, but it is not actually optimal. See, since we have bars of height greater than 4, so if you want to make a rectangle of length 4, you can easily do that. But to do that, what you have to do, you have to cut out the rest of the part. And again, remember that we have to maximize the area. We don't have to minimize. We are not asked to minimize that. So if you are cutting out certain part of bar, you are actually minimizing. Not minimizing, but you are making it less than what you would have got. So this is not optimal. So you can clearly see it is only optimal to make rectangles with height which is present already in the height array. Basically the heights that are already present, right? If you go ahead and do the cutting out the rest of the part, you are actually making it smaller than what you could have already achieved. So it is always optimal to make rectangles with the height that are already present in the height array. Make sure that you understand this observation and this point clearly before moving on further. Okay, now solution. So how we'll be building the solution? We'll be building the solution one by one, and for each height what we'll do, we'll try to find the maximum area. What does that mean? Just try to think over this statement and try to come up with how you could achieve this. Okay, now while you are thinking the solution of this problem, I have a great news for you guys. In the last few days, a lot of you have been hearing about re-level tests, and some of you have registered for the test as well, right? But a lot of you have told me that you were not able to register for the test for multiple reasons, and that is understandable. But today I have some exciting news for you that re-level has announced all of their tests completely free of cost in order to give you, the candidates, access to 1,000+ jobs across top companies. Your search for finding the right job ends with re-level. You can register for the re-level test in just 5 steps. So go to the link provided in the description of the video and then click on login and go ahead and sign up. Right after that, you can select the test of your choice, be it business development, front-end development, or back-end development. After that, you can choose a slot when you want to give the re-level test. Slots are limited, so I suggest you book it fast. The last 2 steps are to create neat video resume. This is actually the 4th step. So in the video resume, you can talk about yourself, your experience, and your career aspirations. And the video resume should be submitted within 24 hours after selecting the slot to confirm the slot. The 5th step is to, of course, click submit and confirm your slot for the test. If you are someone who has not heard about re-level, here are some of the benefits to participate in re-level tests. You get 50 plus companies including top startups and unicorns like Cred, Upgrade, Razorpay, Urban Company and many more who are hiring through re-level tests. 1,000 plus job positions across business development, front-end and back-end development. Completely online that you can take it from the comfort of your home. The best part is that you can take this test for free. Finish your test in a single day of your choice and get your re-level score within 24 hours. Once you clear the test with a qualifying score, by the way, which is 700, you will be able to create an amazing candidate profile which will help you showcase your skills and stand out from the crowd. And something that stands out is always noticed by the companies. Also, the candidates will be rewarded with the exciting goodies like MacBook, iPhone, and many more for the highest rank holders in the re-level test. So what are you waiting for? Go ahead and register. So now let's head back to our lecture. So let me explain this with an example. Here you see, we can only form length, height of 1, 2, 3, 5 and 6, right? Because we do not have 4 here. So height 1 can be formed because of this, right? And who can, think about it, who can participate with this? Basically, who can help him create a largest area rectangle of height 1? Who can help? On the left, clearly this can help. On the right, all of them can help, right? So basically you can subtract or erase the rest of the height. So I can form height 1 and width 1, 2, 3, 4, 5, 6, width 6 rectangle, right? So 1 times 6 is 6. So maximum of length 1, maximum area that we can fetch from height 1 rectangle is 6 only, right? Then we have 2 bars of height 2. So basically I can form 2 height 2 different rectangles. So here I can form height 2 rectangle with width 1, 2, 3, 4. Here I can form height 2 rectangle with only 1 width, right? So 1 times 2 is 2 only and 4 times 2 is 8. So clearly 8 is bigger than that. So maximum I have 8, right? Same for length 3. Length 3 you can form only 1 because none of the people, none of the bars on the left can help him, right? None of the bars on the right can help him because on the right we have nothing. For height 5, here on the right this bar can help him create a height 5 rectangle. So we can have 2 bars of height 5. So 2 times 5 is 10. Similarly for height 6 there is only 1. None of the bars on the left can help him, none of the bar on the right can help him, right? So only 6 because 6 height with only 1, 6 times 1 is 6 only. So if you take maximum of all of these you get 10, that is maximum. That's why the height 10 is the maximum area that you can form. Now to find the solution, instead of going height by height, we will go bar by bar, and for each bar I'll see what is the maximum rectangular area that it can form. Okay, so for this you have to find the contribution of others. So for example, if I was to calculate what is the maximum rectangular area this bar can form, you will go to the left and find what are the other bars that can contribute with it, right? So these two can contribute. Now the next one is actually smaller than that, so this cannot help you form a rectangle or of height 2, right? And because of that you will stop till here only. So on the left you have to find a bar, the first bar which is smaller than the current bar, and on the right the same, right? And that's how we'll be able to find out the contribution. If you have that knowledge, on the left who is the first bar which is smaller than me, on the right who is the first bar that is smaller than me, if you have this information you can actually calculate the height of the maximum rectangular area that this bar can form. So what will be the formula for that? See, if on the left you just find the minimum of left and min left and min right, which clearly, for example, if I'm talking about this bar, so min left you already know, this is at index 1, min right is at index what, 6. Why? Because till 5 all of them is good. Basically on the right there is no one which is smaller than that, the current node, so clearly we'll take n itself. Okay, we are working with zero base index system, so that will be 6, right? So the width you can calculate is min right minus min left minus 1, basically between these two endpoints. Okay, between these two endpoints, so basically r minus l minus 1, so that will be like 4. And then you already have, since you calculated with the height, you can calculate just height you already know, right? from the heights array. So multiply width, multiply height, that way you will have it. So 6 minus 2 is clearly 4, 4 times 2 is 8. Okay, so this way you can calculate the contribution of the current bar, so how much it is contributing, and the maximum contribution will be your result, right? Now the question that remains is that for each node, how you can calculate who is the minimum on the left, basically min left and min right. Okay, so for example, for certain node, if none of the nodes are on its left which are minimum than this, so we will save -1 there. Okay, just before 0 we have -1. Okay, and just after 5 we have n. So if on the right hand side there is no one which is smaller than the current bar, basically this, so at this point min r would be n itself. Okay, so the question is how you can calculate min l and min r efficiently. For that you can utilize stack, and in the constant time you can not in constant time, in linear time you can calculate min l for each of the bars and min right for each of the bars. After that, calculating this is just child's play. So the question is, now if you already know how to utilize stack to find min l and min r, you are ready to go. You can skip this part, otherwise I'm going to explain you how that will happen. So for that we have like a stack and min l array. So first we are going to calculate min l for each height, who for each bar who is on the left which is smaller than this height. Okay, so we'll start from the 0th bar. So what we'll do, first of all, from the stack we will remove all of the indices who are having higher height than this. Okay, so clearly the stack is empty for now. So since the stack is empty, that means there is no one on the left which is smaller than this, so we will insert -1. So basically for 0th index there is no one on the left which is smaller than this. After that, after processing the current index, you will insert the index in the stack, so 0 is there. So now we will calculate the same for the first index. Okay, so from the stack remove all of the indices which is having higher height than this. Okay, so clearly index 0 is having higher height than this, so remove that. After that, stack is empty, so you can't do anything. If the stack is empty, clearly on the left there is no one which is smaller than this, so we will insert -1 at index 1. Okay, now after that what you will do, clearly you will insert the index which you processed recently, which is index 1. After that you will go for index 2. From the stack remove all of the indices which are having height greater than 5. So index 1 is having height 1, so clearly you won't remove it, right? After that you will check whether stack is empty or not. If stack is not empty, that means for this bar there is someone on the left which is smaller than this, and that will be top of the stack. So here you will insert top of stack which was 1, and also insert 2 back to the stack. Similarly you will process for 6, remove all indices which is having higher height than 6, no one is having that. After that you will insert top of stack into the min left, right? And after that what you will do, you will insert the index in the stack also. After that you are going to process index 4. For that, remove all the clearly bars on the left which are having height greater than 2. So clearly this and this, I'm saying a lot of clearly, sorry for that, height 3 and 4, both of them basically indices 3 and 4, 3 and 2 having height greater than 4, so you will remove 3, you will remove 2. After that, this is not greater than 4, so we will stop here and we'll check whether stack is empty or not. Stack is not empty, so top of stack will be inserted here. So basically for index 4 the min left is 2, right? Here you will stop, min left is 1, sorry, my bad, here. So the same way you are going to process for 5. So you got the idea how to calculate min left, right? The same way you will process for 5 as well. I have not completed for that. So if I show you the same in the code, here you see this is min left and this is min right. Okay, so what we are doing, we are running a loop from 0 to n minus 1, right? And this is the first step. While the stack is not empty and the top of the stack is having height greater than or equal to the current height, right? So what we do, we remove them, right? So stack dot pop. After that, if the stack is empty, initialize min l to -1. If the stack is not empty, min l will be the top of the stack, right? As simple as that. After that, what you do, you push the current index into the stack, right? This way you calculate min left, right? And how to calculate min right? It is same, just you process from right to left. Okay, simply copy paste and process from right to left, starting from n minus 1 to the 0 and perform the exact same thing, right? And also, if stack is empty, this time min r is not going to be -1, it will be n, because that means if the stack is empty, that means on the right you have no bar which is smaller than u. That means what will be there? There will be n. Okay, so keep that thing in mind. After that, there's nothing, just calculation of area. For each bar we will calculate r of l minus r of I minus l of I minus 1. This will be your width. Height you already know, height into width is your area, and maximize the area. Finally, return the result. And also you see here, it is possible, since I'm using the same stack, it is possible that after processing these, there are some nodes, also some heights left, some indices left in the stack. So I'm simply clearing out the stack before using it to calculate min r. So yeah, this is the solution of this problem. So I'll be providing the link to this solution so that you can use it as reference. So this was all for this lecture. Thank you guys for watching. If you still have any doubt or query, or suggestion, you can post it down in the comment section. So thank you guys for watching. Till the next video drops, keep coding. Thank you.